In this example, we will solve an assorted mix of questions. In part A, the graph of y equals the base 3 logarithm of x can be transformed to the graph of y equals the base 3 logarithm of 9x by either a stretch or a translation. What are the two transformation equations? Bring up the graph of y equals the base 3 logarithm of x. Begin with the horizontal stretch. There is a horizontal stretch of 1 over 9. Now we'll find the vertical translation. Expand the logarithm using the product law. This gives us y equals 2 plus the base 3 logarithm of x. There is a vertical translation 2 units up. The transformation equations are y equals f of 9x and y equals f of x plus 2. Now we'll move on to part B. If the point 4, 1 exists on the graph of y equals the base 4 logarithm of x, what is the point after the transformation y equals the base 4 logarithm of 2x plus 6? Bring up the graph of y equals the base 4 logarithm of x. Rewrite y equals the base 4 logarithm of 2x plus 6. Factor 2 out of the binomial. There is a horizontal stretch by a scale factor of 1/2 and a horizontal translation 3 units left. The new point is -1, 1. In part C, a vertical translation is applied to the graph of y equals the base 3 logarithm of x, so the image has an x-intercept of 9, 0. What is the transformation equation? Bring up the graph of y equals the base 3 logarithm of x. A vertical translation is represented by the equation y equals f of x plus k. This means that the image is y equals the base 3 logarithm of x plus k. Replace x and y with the point 9, 0 found on the image. This gives us 0 equals 2 plus k. The result is k equals -2. There is a vertical translation 2 units down, so the transformation equation is y equals f of x minus 2. In part D, what is the point of intersection of f of x equals the base 2 logarithm of x and g of x equals the base 2 logarithm of x plus 3 minus 2? The point of intersection occurs when f of x equals g of x. Write in f of x and g of x. We need to convert 2 into a base 2 logarithm. We can do this by multiplying it by the base 2 logarithm of 2, a logarithm that is equivalent to 1. We can condense using the power law in reverse. Two squared equals 4. Condense using the quotient law in reverse. By the equality principle, we can set the logarithm arguments equal to each other. Cross-multiply. This gives us 3x equals 3. The answer is x equals 1. Now that we have the x value, we can plug it into either function to get the y value. In this example, we'll use f of x. Rewrite f of x equals the base 2 logarithm of x. Now plug in x equals 1. The base 2 logarithm of 1 equals 0. The graphs of f of x and g of x intersect at the point 1, 0. If we draw both graphs, we can see the point of intersection at 1, 0. Now we'll move on to part E. What is the x-intercept of y equals a times the base b logarithm of kx? Rewrite y equals a times the base b logarithm of kx. At the x-intercept, y equals 0. Divide both sides by a. This gives us 0 equals the base b logarithm of kx. Convert to exponential form. b raised to the power of 0 equals 1. The answer is x equals 1 over k.